All right, domain and range of discrete functions notes. So a discrete function and a continuous function are two very different things. Okay, a discrete function is a function where you can list all the points. All right, this often looks like a scatter plot, something like this. Okay, that's a discrete function. You can list all the points. A continuous function is the opposite of that, right? You cannot list all the points. So points cannot be listed. We'll say all be listed. Okay, and this graph always has some kind of line or curve, right? We cannot list all the points on that line because there are too many, right? And so that's a continuous function. There's almost always some kind of line, right? The points are connected. Now the domain, right? Domain, you guys, remember, it's just a fancy way to say x values. All right, so domain are just all your x values. And then the range is my other one. Range is all my y values. So we're going to look at problem number 1 here. What is the range? And I want you to stop. You read the word range. What is range? All the y values. So what are all the y values of the function? Y equals 2x plus 7 when the domain is, and again, stop. Domain just means x, right? When all the x values are 1 and 3 and 5. So you're given this equation. You're given these x values. I'm going to make a table here. My x values are 1 and 3 and 5. And remember, I know they're x values because it said domain. Okay? All right. We need to find the range. We need to find these y values. Okay? And I'm going to use this by, I'm going to do this by using my calculator. I'm going to put this in my calculator. Okay, so over here in y equals, we're going to go ahead and we're going to put in 2x plus 7. Now I want to fill in my table, so I'm going to go to the table in my calculator. Do you see this word right here in blue, table? So we're going to go second graph, and that's going to take us to our table. Now I was interested in the values where x was 1. When x is 1, y is 9. Okay, so that's the value that I was looking for. When x is 1, y is 9. When x is positive 3, y is 13. And then when x is 5, y is 17. So that's my answer. Those are my range values, right? Those are my y values. So my range is 9 and 13 and 17. Problem number 2 is almost identical. The only difference is that they don't say y equals, they say f of x equals. But we know that that is the same as y, right? So they've given us this equation. I'm going to put this in my calculator, and I'm going to use these points, right? These are my points that I've been given. Now again, they told me what is the range. So I know I'm looking for the range. I'm looking for the y's. The domain is, so these values they've given me are x values. So I'm going to make my table xy. My x's are negative 4 and 2, and negative 2 and positive 2. And now I just use my calculator to fill in these y values. Okay, so my new equation, I go to y equals again, clear this one out, and I'm going to do my new function. All right, so I want a fraction. I like it when it looks like a proper fraction, so I'm going to go to alpha y equals, and this first option is the one that I want. And I'm going to type in 3 on the top and 2 on the bottom. I'm going to click over to get out of this thing. And I've got parentheses x plus 2. All right, now I want to fill in my little table over here. So I'm going to go to my table in my calculator, second table. Okay, I'm looking for when x is negative 4. So I'm going to go up till I see it. Okay, there it is. So when x is negative 4, y is negative 3. Let's write that down. When x is negative 2, y is 0. Then when x is positive 2, y is 6. Okay, so my range for this problem is negative 3 and 0 and 6. Now remember, these functions we're looking at are discrete in this way because they've given us specific x values and we're looking at specific y values, right? So we can list all the points in the domain for a specific, all the points in the range for this specific domain. Now we're going to go on and we're going to look at this next section. Find the domain and range of the following relations and determine if they represent y as a function of x. Determine if they represent y as a function of x. Now this is a phrase that we haven't really talked about, but all it means, they're asking you, is it a function? Be prepared on your exams, on your tests. This is the way they ask these questions. They don't say, is it a function? They say, determine if they represent y as a function of x. So let's look at number 3. They're asking us about the domain. Well, domain are just my x values, right? So my domain are just these numbers, and we're going to write them in order from least to greatest. Here we go, -4, -1, 3. Okay, that's it. And now we're going to look at my range. Okay, my range this time are just going to be my y values. Okay, so my y values are right here. And we've got 2 and 5 and 6 and 9. So all 4 of those are my range values. 2, 5, 6, 9. Is this a function? No. How do I know? I know because in a mapping, -1 goes to 2, but then -1 also goes to 6. Same thing with 3. It's going to 5 and to 9. Remember, in a mapping, it's not a function if x values have more than one arrow, because that means they have more than one y. It's not a function. Okay, on the next one, we've got our domain and range, so we're looking at these points. I find that students make lots of mistakes just looking at a graph, so I'm going to make a quick table. And I'm going to list each of my points in my table. All right, the first one's in blue. So that point right there is -6, -4. The next point I'm going to look at is here. This point is -2, +1. Okay, the next point is on the axis, so I didn't go left or right, so my x is 0, but I went up 1. All right, my next point is down here. I went right 3 and down 2, so a -2. Then I've got this point, which means I went right 7 and up 4, so they're both positive. And my last one went right 8 and up 4. Now this makes listing my domain and range super quick and easy. Super quick and easy. Here are my x values. These are my domain values. So my domain includes the numbers -6, -2, 0, 3, 7, and 8. Okay, those are my domain values. Now my range values are going to be the ones on the right side this time, right? My y values here, sorry, those are my range values. My range values. And those numbers, remember we want to go from least to greatest and don't repeat numbers. So I'm going to start with -4. My next smallest number was -2. My next smallest number was 1, which we don't need to write twice. And then 4, which again, we don't need to write twice. Is this a function? Well, based on my graph, yes it is, right? Passes the vertical line test. There is no point on my graph that would fail the test, right? 1, 1, 1, 1, 1, 1, right? All my lines only hit my graph one time. Passes the vertical line test. All right, last two problems here. On the back, we're looking at points, right? A list of points. If the table is helpful to you, you could make a quick table out of these points, just kind of like we did in the problem above, if you want to do that. See, 3, 9, 1, 10, -2, -4, and then it's just exactly like the problem we just practiced. I don't usually do that. Usually I color code mine or circle them or something. So my domain values are all the first numbers in my coordinate pair. And I'm just going to list those from least to greatest. My smallest one is -2, and then 1, which I have a couple of times, and then 2, and then 3. Okay, now my range are all of my y values, so -4, 7, 9, 10, and -4. So again, list them from least to greatest. So -4, had that a couple times, and then 7, and then 9, and then 10. Is this a function? No. X values repeated. Remember, we saw the number 1 2 times. Okay. Finally, we have our word problem here. Now, this problem is not a hard problem mathematically, but the phrasing here is fairly difficult. Okay. A plane can carry a maximum cargo weight of 160,000 pounds. A company uses one of these planes to ship 2,000-pound containers. The total cargo weight is a function of the number of containers in the plane. We're going to focus on that sentence here in a second. What is the greatest value in the domain for this situation? Well, first of all, they're really asking us what is the greatest x value, right? Because domain means x. Now, here's the key to this problem. You know they're asking for the greatest x value, but you're really not sure what x values even mean for this problem. Are they talking about the total weight? Are they talking about the number of containers? What are they talking about when they say x or domain? Here's the key. It all comes back to this phrase we saw earlier, y as a function of x. We're going to look at that down here again. Y as a function of x. So we're going to say y as a function of x. Okay, it's always in this order. We're always going to see y as a function of x. So you're looking for this phrase, as a function of. And if you can find this phrase in your word problem, you're going to be able to answer this question. Okay, it's here. Is a function of. Okay, now the y always comes before this. Y as a function of. So we're talking about the total cargo weight, right? That came before the word is a function. So y is a function of. The total cargo weight is a function of. So y, we're talking about the total weight. Afterward, we saw the phrase, we see x is a function of x. And our word problem is a function of the number of containers. So that means that we're talking about x values here. Finally, this problem is making sense. I can decipher what they're really asking me here. They said, what is the greatest value in the domain for this situation? What is the greatest x value in this situation? In other words, what is the greatest number of containers, right? We figured out that was x, which is the domain. What is the greatest number of containers? Well, that's not hard math. Right? That's not hard math. We're just talking about this plane here, right? It can carry 160,000 pounds total. Each one of our things weighs 2,000 pounds. So to find what we can hold, we're going to say 160,000 total possible pounds divided by 2,000 pounds for each of these containers. How many containers can we carry? 160 divided by 2 is 80. So 80 containers. All right, so to sum up, if you get a problem like this where they're asking about domain and range and functions, find this special phrase, is a function of, and that'll allow you to kind of understand the problem better.